So what we're doing here is polynomial sketching when degree is greater than or equal to 3. So we're looking at sketching cubics and anything with x to the power of 4, etc. Many types of polynomials, so we're going to have a look at those first. The one that you do know is parabolas. Of course they're x squareds, and of course you can have a negative parabola which is flipped upside down. We can have a cubic which starts at the bottom and heads upwards, and that's a positive cubic with x to the power of 3. A negative cubic goes in the opposite direction. It starts at the top and sort of works its way down. So it's a negative cubic. So it's anything where you've got negative x to the power of 3 within your equation somewhere. This one here is called a positive quartic. And if you notice is that both ends are heading in the same direction. Anything with an even power the ends will head up in the same direction, unlike, for example, x to the power of 3 heads off in different directions. If you've got a negative quartic, both ends head off in a downward direction. Kind of relates a little bit to a negative parabola. We've got this one here, and you can see they're heading off in different directions. That would indicate that you've got an odd power, and this one is actually called a positive quintic. So it starts at the bottom and heads to the top, and of course you've got a negative quintic. So quintuplets, 5 kids, so that's x to the power of 5. So that's a negative one, of course, has a negative x to the power of 5 somewhere in it. But what we do notice about all of these graphs is that they've all got at least one maximum or minimum, and sometimes more than one, and or some points of inflection. So to sketch a polynomial, any of these graphs, you need the x-intercept. So what you do, put y equals 0 and solve. In fact, there could be more than one intercept. The y-intercept, you put x equals 0 and solve it. Find any maximums and or minimums, and we do that by finding f dash of x is equal to 0. Find any points of inflection, so that's when it changes from concave up to concave down, and that's f double dash of x is equal to 0. So we're going to do this example here. I have got it both in factored form and expanded form. Both are actually very helpful. So first of all, we're going to find the x-intercepts. Now the most useful thing to do would be to use the factored form for this, because we're going to let each of the brackets equal 0 to be able to solve that, just as you would for a quadratic that is similar. So we let each of the brackets equal 0, so when you've got x minus 2 is 0, we get x equals 2. For x plus 1 we get negative 1, and for x plus 3 we get negative 3. So the next step is to find the y-intercept, and we put x equals 0 and solve. So just put it into any of the equations. I've just put it into the second expanded version of it, and you see most of it is equal to 0, and I'm left with y equals negative 18. The third thing to do is to find any maximums and minimums, and we do that by finding f dash of x equal to 0. So first of all we differentiate, so x to the power of 4 becomes 4x to the power of 3, 5x to the power of 3 becomes 15x squared, x squared becomes 2x, minus 21x becomes minus 21. The negative 18 just drops off. Now we put that equal to 0. Okay, here we're solving a cubic, so we can use a calculator for that. And what you do is just put it into the equation part of your calculator, go to polynomial and put in degree 3. Degree 3 because x to the power of 3 is your highest power. Then you insert your coefficients. So we've got 4, 15 and 2 and negative 21. once you've done that, you'll get the answers of x equals 1, negative 3, negative 1.75. We calculate the y values just by substituting into either one of the original equations at the top. And we'll do that shortly. So we've got f dash of x equals 4x cubed plus 15x squared plus 2x minus 21. So we can find f double dash of x, and we just differentiate it again. Why f double dash of x is important is that we can use it to prove whether our stationary points are maximum and minimums, and we can also find any points of inflection. Stationary points are when x equals 1, negative 3 and negative 1.75. So when x is 1 for the first one, we're going to find out what our y value is. Just substitute 1 into either one of those equations and we find out that y is negative 32. So we've got the first point of 1, negative 32. Now we're going to use f double dash and substitute 1 into it, and then we find out that we've got a value of 44. The fact that it's 44 does not have too much meaning for us at this stage, but the fact that it's positive does, and because it's positive it makes it a minimum. We'll do the same for when x is negative 3, and we substitute negative 3 into there and we find out that it equals to 0. So we've got another point at negative 3, 0. Again we put it into the f double dash and we find out that it's 20. The fact that it's positive 20 indicates that it's a minimum. And the last point is y equals negative 1.75. So we'll find our y value first is 4.3945. And our f double dash equals negative 13.75. The fact that it's a negative indicates that it is a maximum. The last thing that we do is find any points of inflection. Now remember, a point of inflection is when it changes from concave up to concave down. So we find f double dash of x and put it equal to 0. So we find our f double dash of x from the top. We put it equal to 0. Again, using the calculator to find out that our x is negative 0.0685 and negative 2.431. Substitute into the original equation, so one of those two equations at the top, to find out our points of inflection. And we get 2 points when x is negative 0.0685, our y is negative 16.6, and when our x is negative 2.43, our y is 2.05. So what we're doing is using the information that we've got, and we're going to put this information on the graph. X-intercepts are at 2, negative 1 and 3, so 2, negative 1, and negative 3. So there's our 3 x-intercepts where it crosses the x-axis. Our y-intercept is at negative 18. And we've got our two minimums at 1, negative 32, which is down here somewhere. And we've also got one at negative 3 and 0. And we'll just indicate that that's a minimum by putting a little scoop there. And we know that it's at negative 3, 0, and we know that that's a minimum there, so we can do a little scoop there showing that it's a minimum. Our maximum is at negative 1.75, 4.395, so that's about at that point there. Okay, we've got our points of inflection too. Now that just changes from where it's concave up to concave down. So they're not significant, but you could plot those points as well. But now we've got enough information, oops, that's a maximum there, to draw our graph. So we can see that's flicking up there, so we're going to go up there. That's going to come over that way. We need to go through this point down on the y-intercept. We're going to go down to our minimum here, and we know that it has to come up through the 2 here. And that's how you draw your graphs. Now your points of inflection are at negative 6.085, so it's at this point here, it changes from concave down to concave up, and at negative 2.43, so at this point here, changes from concave up to concave down.